Okay, so looking at this particular picture right here, we have some symbols that we need to refamiliarize ourselves with. And these symbols are, first of all, that word perpendicular. Perpendicular means 90-degree angle. That means it intersects at a 90-degree angle, okay? And perpendicular always looks like this. When you have two lines that are perpendicular, they create that right angle, which is also why when you have a right triangle, you have that angle in the corner, because the two legs of the right triangle are perpendicular. So that's what perpendicular means. In the figure below, it says that J is, and then it gives you these little vertical lines. That means parallel. So line J is parallel to line M, and you can indicate that with little arrows. You can fill them in however you want to do it. And it tells you that M is perpendicular to R. So here we go with perpendicular again, as I got rogue. So here's M and here's R. They're perpendicular, which means I've got right angles here, okay? So now that I've established that, it says, based on this information, which statement can be proven true? Okay, I'm gonna zoom out just a little bit so you can see the answer choices. Okay, so let's scooch up, and you can see here, let's look at the answer choices one by one. You've got 4 of them, and let's eliminate the ones that don't make sense. So the first one says triangle GHK is obtuse. Okay, here's GHK. GHK. This says it's obtuse. Well, obviously it's not obtuse. Because of this statement, perpendicular, what kind of angles are these? Right angles, which means this is a right triangle. A triangle cannot be a right triangle and an obtuse triangle at the same time. Remember? It is either right, acute, or obtuse. It cannot be both. So this is not obtuse. Angle GKH is a right angle. Now we have to remember how to follow angle patterns in our letters here. GKH, that means K is the vertex. So if I go from G to K to H, is that a right angle? No, it's not. It can't be. It's impossible, because remember, what do the angles of a triangle always add up to? 180, right? We already have perpendicular established. We already know that's a right angle. So you can't have 2 right angles in the same triangle. So that's not true. Okay? The next one says that GHK is a right triangle. You see the triangle symbol, and notice the difference between triangle and angle. And that is your answer. That is correct, because we've already established that GHK is a right triangle. That's the correct answer. If you look at the next question, just to kind of see how crazy this is, GFK is this to this to this. That's a straight line. That's not even an accurate angle. So that should be a red flag right there that that's not the correct answer. And then GHK is this one, which we've already established as a right angle. So it can't be equal to GFK, which really isn't even an angle by our definitions. So that's how you establish with that particular picture. So if you move on and you look, let's go ahead and go to 24. And I'm going to skip 24 because I believe we have taken that one off the exam. So let's go and hop over to 25. Okay. So if I go to 25, 25 says this is the triangle inequality theorem. Now, if you guys remember triangle inequality, the triangle inequality theorem states that when you have a triangle, the 2 smaller sides have to sum up or add up to a value that's larger than the 3rd side. That's the only way you can form a triangle. So what you're looking for here in this answer is you're looking for the 3 lengths here in which the 2 smaller lengths add up or sum up to a value greater than the 3rd one. Now, don't look at the word problem and freak out. because a lot of you guys look at word problems and you decide you don't want to do it, you don't want to read it. Sometimes the word problems might be some of the easier questions you have if you would just read through them. So this one says Michael is building a triangular garden and Joey's willing to give him fencing for it. But the sections of fencing that he's willing to give him are all different lengths. Here are all the fencing lengths. Okay? So which one of these could actually make a garden? Now the question is missing here, and the example how to do it. I guess when I put the pictures on here they didn't show up. So it should say which lengths can Michael use? So basically which lengths can Michael use means which of these three lengths could actually make a triangle. And remember, triangle inequality, the two little sides have to add up something bigger than the larger side. So first one, 5.4, 3, and 9.7. So what are my two baby sides? 5.4 and 3. Is 5.4 plus 3 larger than 9.7? And the answer is no. 5.4 plus 3 is 8.4. That is not larger than 9.7, so that won't work. B, 2.5 and 3 are your baby sides. So 2.5 plus 3, and we got to compare that and see if that's greater than 8. Is that true? No. 2.5 plus 3 is 5.5, which is not greater than 8. So let's look at C. 3 and 5.4 are the baby sides. So is 3 plus 5.4 greater than 6? And the answer is yes. So those are our lengths. So that's the answer that we have for this one. Those are the only three possibilities, and for some reason D is the same as A anyway, so you could toss that one out. But remember, the two smaller sides have to add up to something larger than the bigger side, the third side. So if you look at the next question, you're looking at the same principle here. You're looking at the same idea. So now, same thing. So which lengths can Sandra use? And apologies for not having the questions show up. So which lengths can Sandra use? Well, again, you take the two small sides. So for A, 2.4 plus 4.4, and we want to see, is that larger than 9? And the answer is no, it is not. B, 2.5 and 7. If 2.5 plus 7, is that greater than 9? And if you look at it, 2.5 plus 7 is 9.5, which in fact is greater than 9. There's your answer, you're done. So that's how you apply the triangle inequality theorem.